Let's go over algebraic manipulation. This is going to be really important for a introduction to calculus class, or just if you're being introduced to calculus. So let's take this function x squared plus 2x plus 1 over x plus 1. And we're going to see here that if we find the limit as x approaches to negative 1, the f of x, we're going to get the denominator as 0 because if we direct substitute it in, we'll get 0. So then, the safest way, we can determine limits, and I feel like for me it's the safest way. Just check from the left-hand side and the right-hand side and see what it approaches. But there's an even easier way when it comes to simple polynomials divided, or just simple rational functions, and that's algebraic manipulation. And we see here that we can factor this top function, and that's simply equal to x plus 1 times x plus 1 over x plus 1. So you're going to ask, wait, so you just rewrote it, but if we find the limit, it's still going to yield an indeterminate value. We can finally cross these out, giving us x plus 1. And then we can plug the limit in, and we'll get 0. So you might think, okay, that's pretty easy, but why does it work? And the reason this works is because we assume the consistency of the function for all points besides x plus, or besides negative 1. And what that means is if we come over here and we write the function x squared plus 2x plus 1, or x plus 1 squared over x plus 1, we see here that this is a straight line, only because we can cross the top out to get the function x plus 1. But if we come here on a closer level, we see here that negative 1 is actually undefined, which is why we couldn't direct substitution in the first place. But we see here, and let me just write this out in Sketchpad. And we'll use any other number, like 0.2, and we see here that we'll always just get 1.2 squared over 1.2, and we can simply cancel that out. The only exception would be this discontinuity right here, where if you plug negative 1 in, you'll get 0. But we can assume that there is no other discontinuity because they're always just going to cancel out on the numerator and the denominator, which is why we can still cancel it out if we're going to plug negative 1 in, because all other points are just going to cancel out regardless of this line right here. So if x is equal to, let's use a point like negative 9.98, which is just going to give us it's always just going to give us this function right here, this root function, because this algebraic manipulation holds true for all points except for this, and that means that the left hand and the right hand limit are going to be approaching the same value, because we can assume this function holds true for everything besides them. So